Hey, my name is Suyash. I've been playing with just browser like speech to text and audio APIs, and this really gives me a lot of ideas of what I can do. How hard would it be to go from just simple commands to like saying a whole sentence and being able to parse that and do something with that?
I think this is still one more step on top of it. So our current model is just for a single syllabus kind of word, so a single command. But in order to understand a full sentence, you need to build a language model, which is much more complicated. You will use some kind of LSTM or RNN model on top of that. But the base is you have to understand, the simple command first. Just like Google Home, OK Google is 2 syllables. They actually build a model for that.
Okay. I would say that a lot of the image recognition stuff you see now is the result of research that's happened in the last couple of years. That's public and has been, kind of surfaced to this. That I would imagine language type stuff will bubble up over the next period of time.
We are working with Google internal language team to bring some of those models towards public availability. Because currently a lot of those language model and audio model are not available publicly because they are proprietary kind of technology for the most part. Yeah.
Thank you.
Yeah, but I can see a lot of value if you go ahead and hook up your 45-qubit computer, quantum computer, to a cloud system, and then let people choose to, like they do with Google Voice, actually tune your model like it does on Grand Central. So, I mean, there's a way to do that. We were at an event yesterday where one of your people were like, well, this is proprietary. I'm like, yeah, but you always do this with your big data sets, from fusion tables to everything. And there's a compelling value proposition here, business-wise, and also just for the open source community, making a cloud technology available and testing it against you because it builds you models better than that crappy-ass IBM quantum example. Yeah, it's true. It's crap. What's next? They're going to have us send in punch cards and schedule time? Yeah, no. Here's my question. What are some other technology concerns besides the one we talked about earlier about how mobile, especially SSDs without good compilers, don't actually have a way to optimize performance? What are some of the other performance bottlenecks or pieces in the stack for this that you think developers or people in technology should be working on or could work on that would help?
Yeah, I mean, you kind of nailed it. Mobile is an interesting case. There's a few models that'll work mobile-based. From a TensorFlow perspective, we offer TF Lite. It's a little bit of a, that's optimized for a mobile type runtime for native applications. It is a little bit of a tricky hurdle. It has a conversion step like we do, and they have to implement ops for low-level mobile device. So it's not as fast-moving, and there could be some hurdles there.
Yeah, but people will write stuff for Unity's phone.
There you go. Yeah.
Yeah.
Mostly the big bottlenecks in WebGL is the fencing we have to do for pulling the data off of those GL textures. So we say, we're going to do a matrix multiplication 4x4. So we create a 4x4 texture. If it's like a floating point vector we're doing, so it's a vec4.
You can use the browser stuff they're using for VR in browser. I forgot what the name of the project is. It's a terrible name, so it's hard to remember. But they actually kind of cheat a little bit by you doing the rendering client side, all of it. You don't write a texture back and forth. You actually just do it locally. There's some stuff around XYZ coordinates you could do there. It's they had to do that same type of stuff for audio with VR. So
the one thing we're looking at is from the website, that WebGL runtime, it's 120 ops. So to have an op parity, we have to rewrite stuff 120 times in growing. So we're actually pushing the spec. There's a web GPU spec. Compute shaders, those are 2 of our bets that we're looking at, and working with browser vendors to say, hey, this is really where we want to go. Developers want to ship something that supports major operating systems, and we want to have a spec. That's a few years down the road.
Well, you keep dropping it in Chromium, they'll have to do it. Take care. Great. This is one of the best presentations in the last 3 years, and one of the compelling technologies that's going to disrupt our lives. Great job. You guys covered it top to soup to nuts. Good job.
Thanks.
All right. Well, my question was going to be like, what about TensorFlow on non-x86 systems? But then I guess that kind of answers that question.
Okay,
So my
yeah.
true question is going to be, when you get home and you're done working for the day and you want to go out and find some data to work with and you want to import this into TensorFlow, where do you go, or can you talk on like how do you get your data that you play with in your free time, if you do this in free time?
Sure. Hold on a second, my mic just popped off. So Kaggle is a big site with a large amount of data sets if you want to get in and play with it. Everything's a little different. The baseball stuff is stuff that I had kind of had some familiarity with that data set. So it's a matter of just finding that stuff if it's available. The licensing is always an interesting part. Kaggle is a great stop. I think data.gov is one that we've looked at before. So that's actually like U.S. government data that is like public domain. Like collecting data is in like building a legit training set is an exercise in data science, a lesson for the reader. We do have a course called MLCC, Machine Learning Crash Course, that kind of helps you like dive into those specifics. So if you're interested in that, check that out. That kind of gives you some background into like how do I want to curate this training set. Yeah, I mean, I would say in the Brain team itself, we spend a lot of time working with partner X, Y, or Z for obtaining data and all that. Yeah, that's a large part of the ML. We've made it really easy to create neural networks and change the libraries, but the data part is still like a hard part. Yeah.
Hi, I just want to say that both of your presentations were excellent, and I was just fascinated by, I believe, Nick, you mentioned about the accessibility aspect, and I saw the accessibility aspect with the both of your presentations, and I was just curious about how you see technology accessibility from what you're doing. How can that be further pushed? I guess a little bit where I'm coming from is I do legal accessibility type of stuff, so it's like it was just something that really honed true for me. So I was just curious about how you see about not only implementing for like feature stuff like that for implementation, but also just developing on your end to make it accessible for other people with language or hearing disabilities.
That's a great question. So for example, audio data set, right? So there's a lot of language not represented in translation. Mozilla has a project called Open Audio, which I think it has more language than most of the data set out there. So for us is that we want to support any of those open projects, open source projects, to bring models to anybody that is not presented greatly by a lot of the existing community. So yeah, if you have a chance, check out the Mozilla Open Audio project and take a look, see if you can contribute. They're trying to do translation for a lot of different languages as well.
I will say that there's a lot of TensorFlow JS. So there's Ping, myself, my colleague Kangyi. We're the three here at Mountain View, and there's like three, and there's only 6 of us. There's not a lot of us working on this. And that's 6 as of like last week, right? We actually have a lot of community develop, especially in the core library, a lot of core contributions, and people who worked in this space. There's a gentleman, I can't think of his last name, but he's on Twitter. His name is Oz, and he has been doing he's been working a lot in accessibility in the web, and he has like this vision. It's super cool. Look him up on Twitter. Sorry, Oz, if you're watching. I don't remember his handle at the moment, but he does stuff with a face model that like helps drive the mouse, and that might be like kind of right in your wheelhouse of what you're looking at. So Oz has done a lot of stuff on that.
Thank you.
Just wanted to get your thoughts on so Ping, you emphasized the point that how machine learning is very hard for non-PhDs or people who are coming from this background, especially web developers.
Right.
Now, great job, you guys have released for like a JavaScript version of TensorFlow. Do you think there will be other libraries also adopting that and coming on the web? Because I see a lot of those libraries, frameworks, they're Python-based, and it's a learning curve, and and JavaScript or other languages. Do you think there's going to be more,
It's hard. You have a good Python example?
Well, I mean, I just like other languages. Like I do a lot of mobile, so I like Java, I like
Okay.
Swift. So I would like
Yeah.
to, do stuff in
There's
those.
been stuff we've looked at in the office is React Native, and
Right. Yeah.
There's a lot of interest in that and how we kind of make that work. And where does it fit with TensorFlow JS? Where does that fit with TF Lite? I think the great part about Node.js is it's a very large open source community. If there's a will, there's usually someone who's willing to contribute in that way.
Yeah. So yeah, we'll think about like for just for not only for web developer, also for mobile developer, right? So you want to do machine learning, what are the tooling you have? So we kind of gear towards web a little bit, but also for mobile, if you're doing native, React Native, Angular Native Script, or using Unity, all of those, we want to provide tooling for you as well. It may not be us directly, but the community should be able to provide those kind of tooling for you guys. To me, is just like very open to everyone. It could be a hackathon. One day, someone just did it. Yeah. So.
Oz Ramos, that's it. I think it's at Oz Ramos. Is that what it is? Yeah.
Hi, I'm interested in offline experiences for mobile web. I'm curious, how big can these models get, and what are the best practices for getting them onto the client?
Okay. So it depends what you're trying to do. If it's like an image classification, so the scavenger hunt demo that uses MobileNet, that's a pretty good example for what we can run in like a modern smartphone. Depends on your target, right? Like Android's a tough one because you have a large spectrum of resources across a variety of hardware and OS releases. Another tricky part with iOS is mobile Safari doesn't support floating point textures in WebGL, so we have to use quantization techniques to get close, and we've put a lot of effort to make them a little bit more accurate. So if you're looking for like super high precision, you'll probably want to go with the native TF Lite route. It just kind of depends. Do you know what kind of model you're looking at?
No, this is a general question.
Just a general
How
question?
big can these files get? Because I'm a front-end engineer.
Okay.
So, and if you want to get them on the client because you're offline.
How big is MobileNet like 10 meg?
Well, no, MobileNet is about about 10 meg. But we also provide quantization, so meaning we can compress the weight from 32-bit to 8-bit,
Okay.
meaning then you can basically get a 2 meg.
Yeah.
Okay.
Quantization's a fancy term for saying big number into the smaller range.
Yeah, basically
When I
compressing
first
the
heard
weight.
it, I'm like, whoa, that sounds really cool. But it's this big number to small number.
Okay.
I mean, that's really hard to get there, but that's the technique. So.
All right, cool.
Yeah.
Thanks.
So, but usually for a mobile device, mobile web or something like that, you want at least less than 4 meg would be good model you want to use.
Cool.
So for 5 meg, yeah, that would be probably the maximum you could get.
Okay. Thank you.
Hello. This is just a general question about like TensorFlow in general. A lot of the examples that we saw were about like games and these sort of like fun applications that were in like theoretical also. Are there any like social impact like applications of like TensorFlow like currently that's being used?
Depends how far down the rabbit hole you want to get on that. There are a few data sets that allow you to train models for speech sentiment. Like, is this a positive tweet or is this a negative tweet? Is that kind of the realm you're looking at?
Not necessarily, because like for sentiment analysis, there are like tools that use JS that like already do that, but like more so like less trivial applications. Like, the game looks really fun, and we were looking at the speech application and how we could develop that further. But I don't know, just something of a social impact that's more.
Like a change the world.
Yeah,
type thing?
sort of something like a little warm and fuzzy. That's what I'm looking for. Yeah.
We're here to make the world a better place, right?
Yeah, that's.
There's from a TensorFlow ecosystem perspective. Go to our YouTube channel, the TensorFlow channel on YouTube. There's a really cool video that came out, and I've shown it to people, friends and family that they see machine learning and think I'm building killer robots and stuff. I show them this is more like an impact, and it's a story about a village in Africa where they grow this particular plant. I can't remember the name of the plant, but the plant basically feeds an entire region of Africa, and these plants can get this disease in them, and it spreads from plant to plant, and it can take out large swaths of this crop. So researchers at University of Pennsylvania, I think it is, they built this mobile application using TF Lite and low-end hardware, Android hardware that they can give to the farmers that can actually scan the leaf and detect if that plant actually has that disease, and they can pull the plant and save large crops. So there's a lot of applications like that. There's some rainforest ones. I think we have a Medium post or a Medium blog channel. We put a lot of that stuff there. The TensorFlow channel and the @TensorFlow Twitter handle is good for some of that stuff.
Okay, cool. Thanks.
Yeah.
Hi. I think my question is going to be sort of bigger thing to be offline and maybe just pointers about what I do. And I think it's mainly about sensor fusion. What I'm interested in is autistic kids sort of have movements like this, they do this. And I'm thinking about making a jacket that would have IMU sensors in it that would instrument their arms, knowing the difference of the angle from their core body to their upper arm to their other arms. How would you actually try and do feature extraction from something like that?
Oh, man. Well, with all ML projects, it's curating the data is probably the first part. So, yeah, that's a good question. If you wanted to be scrappy, I think you could probably, if you had the PoseNet model we showed that did the human figure detection, you might be able to take some keyframes and build some stuff off of that from a video perspective.
Yeah, I wasn't thinking of using video. I was actually using sensors.
Yeah, if you're using sensors, then you'll need some sort of apparatus to collect the sensor data and then
yeah,
clean
I
up
could get
the data.
that part easy. It's just how do you? It's like this fusion of all these moving angles or something like that. It's almost like the speech thing. You fuse all those.
Right.
It becomes a data science problem.
Yeah.
Of how you curate it, how you build the model, what type of model you. There's various ways of approaching it.
Okay.
Yeah, I would point at the MLCC.
Okay.
The machine learning crash course, if you wanted to dive into how do I take this sensor data and do something with it, that'd be a good starting point.
All right, thank you.
Mm-hmm.
So was it cassava leaves?
Yeah, that's the plan. There you go.
Well, just to speak to the last guy's last question, there was a video that Google put out a few weeks ago. It was about how a dad and his daughter, the daughter had type 1 diabetes, so he put a Raspberry Pi and he hacked the insulin sensor, so he would track it and then go up and down. And you take that data, put it into the Pi, and then from there use TensorFlow on the Pi, and then back that off.
Yeah, that was actually built next to us. It was done with TF Lite on Raspberry Pi.
Okay.
There's a Medium blog post on that, on the data curation, how they built that model, I think.
Okay. So my next question is going to be, is there anything stopping using another GPU programming or library like Metal or Vulkan?
Sure. Feel free to use Metal. You'll have to write the machine learning framework on top of it to get to Metal.
No,
that's the tricky part with. Or are you talking about
manpower
backends
that's
for?
stopping us from porting it to those extra things, or is it we just haven't? Is there some underlying technology that I can't think of that's we shouldn't go in that direction?
Sure. So Metal and Metal is the upcoming Apple one. So I think at WWDC they announced they were shipping Metal support. The tricky part with any new backend, I think kind of mentioned it, like we have 120 ops and growing on the browser front, and whichever new thing we have to do, we have to write 120 plus whatever else we've implemented. Core TensorFlow is about 1,000 ops. And they're not very straightforward, like, let's sit down for a month and do this. These are like very low end and take a while to implement ops, and have been curated over the last 3 years. So implementing a new backend or a hardware to run these ops on requires time to implement these things. So.
Okay.
Hey, here's a more general question about probably ML, but the idea is, now that we can run machine learning on the front end, how secure it is to like store data from the user? Let's say I run the machine learning on the entire photo library from a cell phone. How secure it is to store the test data or the training data into the like local storage or something like this, or like is it secure to store this way, or should I store this data in a safe way, I might say?
So.
Hey, that's a tricky one.
So first of all, usually you will not train everything on your cell phone. You mostly train on the server. Regarding the weight, there's a couple ways you could secure your weight. One is that you can break your model into two pieces. One on the server side, part of it on the server side, part of it on the client side. So you train part of it on the client side. You only upload, the feature set you want to, it's not very unsecure to the server side. The server keeps all the, all your proprietary kind of data there. So if you're talking about not trying to reveal your model to your competitor, that's one way you could do it. But if you're more concerned about privacy, then you want to keep your data within your edge device, which is your mobile device. You only ship the decision up to your server.
Yeah, because I understand that after we can like run these things on the mobile, we can have a more smooth experience for the offline users. So that I want to understand how secure it is to like store these things, because if you train the data with like personal data, how secure it is to store, and what we can extract from that data. Yeah. That's the major question.
So basically, you're mapping your more user-sensitive data into a feature set, which is not very, privacy concerned, right? So, you can probably ship it to your server side, and without any violation to the rules.
Okay, thanks.
Any other questions? Going once. All right, well, let's have another big round of applause for the speakers.